A galleon ship in the late 16th century Spain leaves the port of Valencia and heads off to the Philippines via a trade route. The ship leaves the port on a direction of 40 degrees north of east and travels 32 kilometers. Then, the ship turns due east and travels another 27 kilometers. Midway, the crew noticed that a part of their supplies was left behind. The ship's captain then asks you, the navigator, on how far the ship is from the port and what is its direction before making the decision whether to go back to the port or not. This navigation problem is an example of the application of the concepts of vectors in real life. In solving vectors, we have three general steps. First is to graph out the problem and find the vertical and horizontal components of the overall vectors. Second, after identifying the vertical and horizontal components, we can now obtain the resultant displacement using the Pythagorean theorem. And lastly is to get the direction of the angle using the concepts of trigonometry. In finding the vertical and horizontal components of the overall vectors, we must first identify each of the components of the first variable vector and the components of the second variable vector, and sum them all up. Next, we let x in our equation be the horizontal component. Thus, using the given formula, we have ax as the horizontal component of our first variable, wherein it is equal to the value of our quantity multiplied by cosine and by the value of the given angle. If we apply the needed values, then we have 32 km times cosine 40 degrees. Next, we solve the remaining equation using a calculator. Then, we now have 24.51 kilometers due east for the horizontal component of our first variable. For the second variable, the bx or the horizontal component is already given because the quantity only has magnitude but no direction. Next is to sum up all our identified horizontal components, wherein the formula we will use is Rx is equals to horizontal component A plus horizontal component B. Then, we put the needed values and equate. All in all, we now have 51.51 kilometers for our horizontal component. Afterwards, we will now identify the value of the vertical component. At this point, we let y be the vertical component in our equation. Then, we will use the given formula for the vertical component, wherein ay is equal to the value of our quantity multiplied by sine and the value of the angle. Next, apply the given values, then equate. Then, we now have the value of our vertical component, which is 20.57 km due north. After identifying the vertical and horizontal components, wherein our components are already perpendicular and is in a 90-degree angle, we can now look for the resultant displacement or the hypotenuse by applying the Pythagorean theorem. In the Pythagorean theorem, the formula is triangle side C squared, or the hypotenuse of a 90-degree angle, is equal to the sum of the squares of sides A and B. Next is to apply the needed values of the formula, then equate. Thus, we now have 55.47 kilometers as the hypotenuse or the distance of the ship from the port. And lastly, we will get the direction of the angle using the tangent concept of trigonometry, wherein the opposite and the adjacent sides of the angle in a triangle are used if identified. For the formula, we have theta is equal to the inverse of tan multiplied by the quotient of the opposite and adjacent angles. We then apply the needed values, then equate. Now we have 21.8 degrees as the direction of the ship from the port. Now, we can tell the captain of the galleon that the ship is 55.47 kilometers away from the port at a direction of 21.8 degrees north of east.